Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics of the quality control, that is alkali-silica reaction. It is very much important to know what is alkali-silica reaction, how it is affect the concrete, and what is the remedial measure. So today's video, we will discuss each and everything about the alkali-silica reaction in the concrete. So stay tuned until the end to get the full information. And if you are new on my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, alkali-silica reaction in concrete. It is very much important, so do not skip any part of the video. Stay tuned until the end to get the full about the alkali-silica reaction. First, what we need to know about alkali-silica reaction is introduction to alkali-silica reaction, that we need to know what is the alkali-silica reaction. Is a chemical reaction that occurs within concrete. It's also known as concrete cancer due to its damaging effects on concrete structure over the time. So it is an alkali-silica reaction, commonly known as ASR. And what is ASR and why it is it, I will come later. But why it matters, understanding ASR is crucial because it can lead to severe deteriorations in concrete structure, resulting in safety concerns, structural integrity, loss of costly repair. So this is the cancer of the concrete. That means it is reducing the concrete lifespan, structural integrity. So we need to avoid in alkali-silica reaction in order to get the structural stability. So next part is mechanism of alkali-silica reaction. What is happening actually? This chemical process. What is a chemical process? The ASR mechanism involves a chemical reaction between alkalis, that like sodium and potassium, in the cement. So in the cement, we all know that sodium, potassium is present, and the reactive silica present in certain aggregates. What has happened? This aggregate is where it is from the natural sources. So it is possible that there must be some reactive aggregate. So what is happening? This reactive aggregate very much sensitive to sodium and potassium, and they start reacting each other. So and how it can react? It cannot react with each other until and unless there is a presence of moisture. So when moisture is available, the alkali and silica react to form a gel-like substance. So sodium and potassium in the cement and reactive silica in the aggregate and moisture. If these three are in place, then alkali silica reaction occurs. Then what is happen when this gel is forming? This gel absorbs water and expand, so creating internal stresses. So inside the concrete, gel is forming, and what is happening on the gel form? The volume is increasing, and when the volume increases, internal stress is developed, and over times it expands gel, causes cracking and deterioration. So cracks is happening, the spall is happening. So how the cracks is appearing? This like spider is here, you can see the spider like appearance is coming when the alkali silica reaction is happening. So what is the impact? The impact is that internal stresses generated by the expanding gel are sufficient to create cracks that weaken the structure, reducing its durability, as we discussed. The next part is condition required to ASR to occur. So already we have discussed what is the reaction, that is calcium, potassium and sodium in the cement, aggregate reactive silica in the aggregates, and moisture availability. So concrete must have a high alkali content casually, usually from the cement. This high alkali cement release more sodium and potassium. That is the main substance for the ASR. And then reactive silica in aggregates. Then moisture availability. Water plays it a critical role or the crucial role. Without the moisture, this ASR cannot happen. So ASR moisture is also have a great role to start the reaction of ASR. So these three are when are present in the concrete, then this alkali silica reaction started and it deteriorated the concrete lifespan. The next is Effects on ASR on concrete, that already is this crack can happen, this map like cracks, and if the crack is there, then structural deteriorations, and it is increasing the permeability. Why? The cracks is generating. Now these cracks become the weak spot or weak zone to entry the moisture, sodium, calcium, sulfate, carbon dioxide, etc. That are also affecting the carbonation of concrete. Chlorine, that means chlorine induced corrosion of the steel. So all these will happen, and when this permeability increasing due to ASR, it again deteriorate the concrete because of carbonation, because of chlorination. So whatever the causes, it is increasing. So it has the detrimental effect. Not only ASR increases the cracks, increases the spalling or the concrete deterioration, it also increases the permeability, which again is the path to enter the all other chemicals, and it start reacting with the concrete and the steel. Ultimately the structural stability is in a problem. The next part is chemical reaction of ASR. How this chemical reaction is happening. The primary chemical reaction can be simplified as alkali-silica plus water and alkali-silica gel. This gel is alkali ions from cement react with reactive silica in aggregates in the presence of water, forming a hydroscopic gel. And this gel absorb water and swell. So first this alkali, silica and water react and in gel form, and this gel again absorb the water and creating expansive pressures within the concrete, which leads to cracking. So this is the simplest form of chemical reaction. I'm not going on to that details how the ion plays, but this is the simplest reaction, that alkali plus silica plus water. This the alkali is coming from the sodium and potassium from the cement, and the silica coming from the aggregate, and then water. So next part is factor affecting alkali silica reaction. That alkali content, all we already discussed, that the higher alkali content increases the chances of ASR. Then aggregate reactivity. Certain types of aggregate like opal or strained quartz are more reactive and thus more likely to cause ASR. Then moisture level. This high humidity can cause the more ASR inside the concrete. Then temperature. ASR tends to occur faster and higher temperature, making it more prevalent in hot climates. So these are the factors which are affecting the ASR or the alkali silica reaction. Then identification of ASR in concrete structure. First, we need to do the visual inspection. Engineer can often identify ASR by looking for map cracking, gel exclusion, or discoloration on the concrete surface. Then laboratory test, we can do some laboratories, not that much of. Simply can be tested by actually in the using petrographic analysis, which examine the concrete under a microscope to identify reactive aggregates, alkali silica gel. That is all not that much of popular, but we can also find out. Then field testing, we can do the field testing, that is NDT and something, to find out the strength and the durability of the concrete. So that is this way we can identify the ASR. The visual inspection and regular inspection is the key to find out not only ASR, any type of concrete deteriorations. The next is effects on ASR durability and the strength, that we already discussed. Again, it reduces compressive strength and the tensile strength. ASR weakens the concrete, reducing both its compressive and tensile strength. So if compressive strength is reducing, that means whatever we intended for the design, we are not getting that much of strength. That means structural stability will be a problem. Then increased vulnerability to other forms of attack. Already discussed that whenever cracks is generating, it is become the weak path to penetrate chloride ion, sulfate ion, carbon dioxide, and moisture. So again, the more deterioration will happen in the concrete due to this ASR. Then also it is the impact on the structural life. ASR significantly shorten the lifespans of creative structures, posing serious safety and maintenance challenge. So these are the effects on the ASR and durability and the strength. Then what are the preventive measure we can take? Then use low alkali cement this is the first point. If you are using low alkali cement, there is a less chance of available of sodium and potassium. So then the ASR will be less in the concrete. Then selecting of non-reactive agents, aggregates. Using aggregates that are known to be non-reactive helps avoid ASR from the start. Then what is the supplementary cementitious material that also we need to use in the concrete, so that it will also helps to reduce the chances of ASR. Materials like fly ash, slag and silica fume can replace some of the cement, reducing the alkali content and inhibiting ASR. Then ASR inhibitors. It is very much important that lithium based admixture can be added to concrete to neutralize the reactive silica, preventing gel formation and expansion. So it is very much important nowadays we are using the lithium based admixture that are preventing to form the gel. So it is not creating the ASR whenever we are using the lithium based inhibitor. So this also we can introduce in our system. Next is repair and mitigation techniques for ASR affected concrete. So what we will do if ASR already taken place in the concrete, we first need to identify. Then what we can, then moisture control is the first thing, because without the moisture ASR will not happen. So first things we need to do the moisture control. Reducing the moisture content in ASR affected concrete can slow down the reaction and limit further expansion. Then surface sealant. We can use a sealant to the surface to ASR affected concrete can reduces water penetration, limiting the reaction. So whatever we are doing, we need to do the waterproofing so that the moisture cannot penetrate inside the concrete, because without the moisture ASR will not take place inside the concrete. Then structural reinforcement. In case where ASR has compromised the load bearing capacity, structural reinforcement such as steel wraps or carbon fiber may be necessary. So it is also you need to identify what how much the area is affected and what is the degree of affection. Then according to that we can play the our prevention measure. But first things we need to prevent the moisture entry, and we need to use the non-reactive silica, and we want to use the low alkali cement and use a supplementary cementitious material, which is the key to reduces the ASR. The next is importance ASR prevention in construction projects. See why it is important to prevent. First is the structural stability, already discussed, the long-term durability and cost. ASR damages can lead to expensive repair or replacement cost if not addressed early on. So there is a cost issue, there is a quality issue, and if ASR is there, the reputation is also a problem. So these things about the importance of prevention of construction. Then future of research and innovation. The new admixture, that is the lithium based admixture we have all in the place. Then better testing and monitoring and innovative materials that we are also in the process to research and innovation that can lead the or prevent the ASR. So these are all about the ASR in the concrete, and I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. Thank you once again for watching me.